after all this AI talk. It's very exciting. I'm stuck trying to buy Shiba wings on your phone. Let's get the panel going. So we'll start first by having each of you do a short introduction for themselves. So,
the name is Ed Prado. I have frequented all of Michael's conferences. These are excellent venues to meet people and to sit on panels like this. I'm the current CEO and co-founder of Rare Technologies, and we have just launched Rare Protocol, which is an open source deployment layer. We're going to talk about that a little later. And we're very excited about AI and the facility where AI and blockchain are going to converge to create some really exciting products.
I am Rex Wong. I'm CEO of HoloAI, and HoloAI is a platform that allows you to create and clone yourself, your own AI twin. We can do that in a minute. Actually, a bunch of you have actually been cloned here already. Next time you do Tokenize, it can be all clones. But yeah, it allows you to clone yourself, and then basically it can talk, speak, think like you in 29 languages. We actually just are going to add sign language as well. And it's verified on the blockchain. So when you create it, we actually verify that, record onto the blockchain. We have a chain called Officially AI. And then all your generations are then tracked because each AI generation is minted, and that's basically our platform.
Rex, can you make me younger and better looking and a better public speaker? Or is it just my clone?
We have a model that you can talk to your younger self and your older self, so yes.
That sounds great. We'll talk later. My name's Dennis Jarvis. I'm the CEO and founder of CETI AI. CETI is an infrastructure company, meaning we deploy enterprise-grade NVIDIA compute specifically to Web3 projects. And we're happy to be providing compute right now to deep-end networks like Spheron and Hyperbolic. And we're super excited to be lighting up our Vancouver compute cluster for the Morpheus Homestead release coming up on November 18th, and being one of the first enterprise-grade NVIDIA compute providers for Morpheus and all the amazing AI applications and agents that run on top of it.
fantastic. And my name is Dr. Adel Misiri. I have a PhD in AI and trust networks, which became blockchain. So I can't tell you how much I am living the dream. I can being here, talking with all of you, and just seeing the field grow up. Not every day where you study something and then it becomes huge. I'm also have a Y Combinator with 3 successful exits. One is a unicorn, 2 flops, and a dozen in flight. My main flagship is AI Valley Protocol, which I'll bore you with tomorrow. But when we talk about AI and think of it as an industry that's coming out there, it makes sense to think about the AI infrastructure. So the way that I want to split it are into 3 different categories. One of them is the hardware, the other one is the software aspects of it, and then the power consumption of those. And I would like to start with a very interesting comparison. Do you know how many AI companies are established globally? Just guess a number. What do you think?
10,000.
10,000. Do I hear more? 10,000 here? 10,000? 10,000?
Way more.
70,000 companies. Yeah, well, good. And actually, one in every 4 of them is actually established here in the US. And the amount of GDP addition to the due to AI is forecasted to be how much? Anybody knows? Roughly $20 trillion by the end of the decade. So it's becoming a huge industry. Now, let's start with the power consumption, and there is a hidden agenda. We have been bored to death with Bitcoin is burning all this energy and all of this stuff. Guess how much energy AI is projected to consume by the end of the decade? 400 terawatt. That's more than what Bitcoin is consuming, and roughly is what the US is consuming. So the demand on energy is going 500x for energy. Ask any energy companies, like in 100 years, we have not seen that expansion of demand on energy. So the first question that I would like to ask the panelists here is, how do you see the advancements in order to reduce the consumption of energy for AI? Alex?
I'll start with this one since we're a direct consumer of electricity with what we do. And I think that there is a lot of opportunity for efficiency to be built into the hardware layer, the software layer for AI, and that's part of what we do. Our software layer, specifically called the CETI Intelligent Compute Fabric, is meant to optimize the use of inference compute across multiple different use cases. But I think that overall, what we are still looking at is an order of magnitude increase in the amount of energy consumption required by AI compute across all industries and in every nation in the world. In fact, just to remain competitive, I think in this space, not even to include things like the electrification of transportation or industry, the U.S. in particular is going to need to double its current electric output by the end of the decade. And that's something that is just going to be, an overwhelming, project or initiative, or however you want to conceive of it, that would require, this particular country that we're doing this conference in right now to, tap into every possible conceivable source of energy that it possibly has, and just to remain competitive in AI, transportation, and industry as we move towards electrification of basically everything. So it's a huge, huge topic to consider, and I could go on for hours and hours about it because this is something that's very particularly interesting to me as a consumer of electricity. But let me give opportunity for other people to share their thoughts too.
Yeah, I think a lot of these more specific like LPUs, like what Grok or I think Cerebellus is doing, and there's a few other companies rumored to be getting in. I think those are going to, so these inference type of processors that are specific to the task are probably going to be, because like Grok and Cerebellus, I think they can compute at 10 to 25 times more efficiency for that specific type of a task, and that's, I think, where you're going to have to get to as the volume increases. But with the consumption of AI just probably exponentially growing, it's still going to be a number that we're going to have to chase.
From an outsider sort of perspective, it's fascinating because in the end, we're going to need AI in order to streamline the efficiency, the electrical efficiency in our power grid to power AI. And that's a big part of it. Like, we're going to have some tools that we've never had access to before. So everyone's like, okay, we've got to double the electricity in the United States. That's like impossible. But actually, when you look at sort of the tools and the resources we have now, and I think that AI is going to open up people's mindset as far as, what's acceptable. Like, everyone's talking about these nuclear power plants. That was like very, very negative, long ago. And now Microsoft just put a play on 3 Mile Island because it's a land grab. And it's going to be all about access to this infrastructure in order to deploy whatever agents and models and the next sort of wave of AI, which is the reality of AI, which is we got to make money on it.
So that's a really good point, and I always want to bring it back into being an investor and think about like, hey, energy sector is going to be a really, really nice for both AI and blockchain from a point of view of being an investor. But that leads me to the second point, which is the hardware. So right now, most of the predominant AI models, like any AI provider, OpenAI, all of those stuff that are using GPUs are basically centralized, where it means that you have those GPUs power hungry and they are all centralized. So I'm wondering about the direction for the edge computing and taking those AI models down, especially with the advent of things like Apple Silicon AI. Samsung is coming with similar thing. So what are your thoughts regarding having the hardware on the lower end smart enough to where it can compute the AI locally instead of having to do it all centralized?
Well, I think that goes back into those those inference models. They're going to build them into basically your chips on your phones. And I think that also goes into the development of small language models. So all these language models they're now making, like, I think the latest like 3 billion llama model is as efficient as the previous or the original ChatGPT model, which was more like 20 billion, right? So those models are shrinking, and the processors on your phones are getting more powerful and with more built-in inference for AI, and so those things converging will allow basically for you to run models on the phone, and we're looking at that right now because for us it's about also the data and your privacy, and right now we have to store it on the cloud, and if you want a decentralized identity, which is part of what we're trying to do, the idea is that the data shouldn't be stored in the cloud, it should be stored locally, and we shouldn't need to see what your data looks like to be able to deliver that AI service.
I'd love to hear a little more about Dennis as far as the edge compute case, the distributed compute. We just did a deal with Akash, and we're bringing Akash our tool set and our resources so that we can build Web3 applications directly on Akash. And interestingly, majority of their business is AI compute. And they're bringing us on to basically further that, and so that they can, build on their vanilla compute and actually sell that off. But I think that the whole concept of distributed compute and like leveraging resources that aren't being used out in the marketplace is going to be a big theme going forward. It's also going to take a lot of market share away from these very centralized, the Googles, the Microsofts. But I'd love to hear what your thoughts are on that.
Yeah, no, that's edge compute is growing at a huge rate as well. I think that I just, in fact, enabled Apple AI on my phone yesterday, like when that was announced. And what you're going to see is that, like, when you have specialized use cases, you can do model inference for those use cases at the edge on a phone, in a call, for example. Those models will still be trained on huge compute clusters. And those models are birthed, from what is being developed for the large, foundational Landguard models that, still require massive centralized compute in order to, be trained and to run. So I think that as, large foundational models produce more capabilities in terms of specific smaller things that can be run at the edge, they're not going to, that's not going to reduce the amount of demand, for large models requiring centralized compute. They're going to be moving on, to the next thing. And I think we're just going to continue to see this evolution of both large and small models that require both huge amounts of centralized compute and, a lot of edge capability as well. So it's just tremendous amount of growth from the edge all the way to the middle and back again in terms of, inference, and certainly a lot of training still going to be done in the large, supercomputer clusters for the time being.
Yeah, so if I may sum that up in the sense of we're going to see more edge computing happening, and we're going to see the AI tasks are kind of like being segregated into things that require centralized, heavier compute, and ones that, like you asking your phone how I'm doing today or stuff like that, that it will be able of processing locally without having to go back and use a lot of those energies, which tells me two things. One, that it gives rise more to the federated AI, to the decentralized AI, and to the chip makers that are going to be investing more into localized AI, as well as to those protocols, like you mentioned on blockchain, that help create that distributed AI. And like Michael Turpin mentioned today, at the end of the cycle, there will be a lot of liquidity, which if I was a betting man, I would say like it's gonna go into a lot of those AIs after we're done with the memes and so forth. But then that leads me to two critical questions. One of them is, can you clone me so that my clone can take the garbage?
And what?
Can you clone me so that my clone can take the garbage out?
So we're the soul of it, and if you pair it with a body, yes. Like if you pair it with Elon's little android and we're the brain, yes, I think we could.
So then that is basically where we are tackling the third aspect of the AI infrastructure, which is the advancements in the application layers and the software of which, and I think you touched lightly on it, Dennis, in the sense of the delineation between heavier models and lighter models. So for example, in my R&D, we are working on trying to build axioms and provide insights into current AI models. So LLMs are notoriously weak in mathematical logic. So when you tell it to compute 1 plus 2, it would not know how to compute that. It has to refer to previous examples of people saying 1 plus 2 is 3. However, with axioms, you can actually refer to the axiom and invoke that axiom to get the answer for it, which means that you can use smaller models but still gain higher accuracy or comparable accuracy to the bigger models that exist there. So what I'm curious to know is the software piece. So where do you see the advancements in the AI infrastructure when it comes to software deployments, networks, and so forth?
Like I mentioned before, this whole convergence of blockchain and AI, because one really needs the other. If you read through, and if you haven't seen it, A16Z put out one of the best reports 2 weeks ago. It's like the state of crypto, and it's a 55-page slide deck. And one of the slides talks about this convergence, and they have a stat on it that blew my mind. In the last year, AI has produced 15 billion images. So you go into your AI, you're like, hey, paint me a picture with the sky blue and whatever. 15 billion images, which they say, just to kind of level set that stat, is more than 150 years of all photography and all photos that have ever existed. 150 years. So you can just imagine one of the most rudimentary problems is going to be, is it real? Is it AI? Is it? And the only thing that could really assist with that is putting something that's real on chain and having provenance. And that is going to happen, you guys. And we're going to talk about that a little bit later with what we're doing at Rare. But this idea of being able to trace provenance and then awarding proper, provenance and payment to whoever actually gave you that information. All this is going to happen, and it can only happen with the blockchain.
Yeah, and that's actually exactly what we're doing with what we call officially AI. So when you create a twin, we KYC you, so we verify your ID. We actually record that onto the chain, and then every generation is actually minted. And so we track each one that can be tracked for provenance, for licensing, royalty, etc. And each generation is actually also fingerprinted so that we can track that physically. So we can tie the physical ID with the we mint like an 1155 on that, right? So therefore you can do different types because we believe of this new AI economy where. And I'll give you an example of that. So let's say you have a celebrity and a brand wants to use the celebrity and they want to create a post but they want to use the AI. So we already validated that that's that official celebrity's AI, right? And once a generation is created for whatever they want to say, and they want to pay them by views because they don't want to pay them up front, they don't know if it's going to work, right? And let's say that's YouTube is the platform. Right, and they'll pay $10 per 1,000 views, and we see 1 million views go on YouTube. We can track it. We know that's the original version because there's a fingerprint on it, and we can track that to the NFT or the RWA, right? And so basically, we can now see that you got 1 million views. The smart contract says $10, so you should get paid. In that case, $10,000, right? So. And we can facilitate that to happen. We can also prevent unauthorized use. So we're launching a protection service because we think that that's going to be the biggest part of the concept of your AI identity or your sovereign identity of your AI, which is, and it's already happening right now. There's a lot of scams happening where, there's one where they're cloning the grandkid and calling the grandparent and saying, "Oh, I got kidnapped. Please help me." That's happening already. So this is not just even celebrities, this is just regular people. And so in a world where cloning, and we're not going to be the only ones who can do that, right? Where you can clone somebody in 10 seconds, what do you know is real and what do you know is not? And so the key that we're trying to address right now head on is trying to verify that identity so that there's a source of truth, and then basically every generation that you're creating, when it's out there, it's fingerprinted. if it doesn't have the fingerprint, it's probably not yours because it wasn't validated. We don't see it, and so therefore, you know, this concept of identity is going to be really important moving forward, and we see that it will drive this new AI economy, but it will also create this kind of scary world that you're going to have to put a lot of protections and guardrails in place.
I think one of the most, from my perspective, again, I'm going to attack this from the hardware angle, from the most interesting challenges that might be applicable to the blockchain space, in particular in software over the next year or 18 months, is how to decentralize model training. And model training is something that requires many tens of millions of dollars worth of compute running in one single data center, months and months sometimes, to complete training a large foundational model. And if you want it to be faster, then you turn that tens of millions of dollars of compute into hundreds of millions of dollars of compute. And so I think that's a really interesting problem, how to take something that is so fundamentally centralized and decentralize it. And I think if we believe in the principles of sovereignty and individual freedom and liberty, and being able to own the models yourselves at an individual or small developer level, then this is a problem that we need to solve. It's something I've talked to David and the Morpheus team a little bit about, and I'd love to talk to others about it as well, because I think it's probably one of the most compelling challenges for AI is when you think in terms of decentralization. How do you take something that is so centralized at such a massive scale and be able to decentralize that as well? It's something I think about. So.
Cool. I think we are getting to the end of our panel. So in 30 seconds or less, your action call. What do you want everybody here to go and do right now?
If you'd like to be part of a community of people, either as a consumer of compute or participate, with CETI as an investor, or just learn more about infrastructure and compute and AI, then please see me after this talk. Visit us at CETI.ai. Thank you.
If you want to create your clone and twin, I'm here. And
Q starts behind me.
And it's protected, and we'll run it on this edge, and we'll protect it on the rear, right?
Yeah. If you're a developer or an L2 or somebody in the ecosystem that wants to affiliate with Rare Protocol, we'd love to hear from you.
And if you are working in AI or have your own protocol and you'd like to be discovered and verified, go to AIVP.ai and join the network. So I think with all of that stuff, it has been a mind-blowing panel about the infrastructure of AI, where we'll be heading. I'd like to thank each and every one of you for spending this time with us to educate us on what's coming next. And thanks to Michael and Joyce for hosting us in this wonderful venue. And I hope to see you next. Thank you very much.
Wonderful, wonderful. Okay, up next, I am super excited about this. We have Bill Min from Twin Protocol, who is going to